It all started one morning when Michael was eating breakfast. Suddenly, he saw his mother do something that looked like magic.
Say, Mom, how'd you do that?
This? It's my new bulletin board. Dad brought it to me last night.
Yeah, but how does it work?
With these little magnets. See?
Can I try it, Mom? Can I play with it?
Of course you can after school. But hurry now and finish your breakfast. You'll be late.
That was Michael's introduction to the magnet. Right after school, he made a beeline for that bulletin board. Strange. It doesn't stick to the wall, although it sticks to the bulletin board. It sticks to the kitchen cabinets, but not to the milk bottle. Wait a minute. The cabinets are metal, and the bottle isn't. Maybe that's the answer. Yep, the bulletin board seems to be made of metal, too. Maybe that's it. But no, it doesn't stick to this metal. What could it be? Michael set out to keep track of the things the magnet sticks to and the things it doesn't. By evening, he had two pretty large piles.
Dad,
Yes, Mike?
why is it the needles are attracted by the magnet and not the pins?
Take a look at the box the pins came out of, son.
What does the box have to do with it? Oh, is it because they're made of brass?
Right.
And the needles, they're made of steel.
Right again.
Everything in this pile is either iron or steel.
Right.
Nothing in this pile is iron or steel.
Yes, Michael has found the answer. Magnets pull or attract only things made of iron and steel. They don't attract things made of anything else in the house.
Look, Mike, I hate to interfere with your experiments, but I have to have that magnet for my bulletin board.
Oh, just when I was getting started.
I'm sorry.
Tell you what, son. Tomorrow, if I can remember, I'll bring you home some magnets of your own to experiment with.
Oh, Dad, you will? You won't forget?
I'll try not to, son.
Oh, boy!
Michael's father didn't forget them. In fact, he brought home 4 magnets. There were 2 U-shaped magnets called horseshoe magnets and 2 straight magnets called bar magnets. And for the next several days, Michael tried all kinds of experiments. He found out everything he could about magnets. To help him understand, he asked questions, and he read up on magnets, too. He had so much fun, he wanted to share it with some of his friends. He decided to put on a magic magnet show.
Ladies and gentlemen, watch carefully, please. I will now make this sailboat move in any direction at my command. Right. Left. There's a storm at sea. I will now show how the force of this wonderful magnet will go through other materials. It will go through cardboard to pick up this key. Now watch. See? It will go through glass to move things on top. It will go through water to pick up nails. This magnet is a horseshoe magnet. Now let me show you another magnet. This magnet is a bar magnet. Where's the magnet the strongest? Let's do an experiment to see where the magnet is the strongest. You see these tacks? Yes. I spread the tacks on the cardboard. Now I place the magnet on the tacks. See where they stick? That's right. The ends are called the poles. That's where the force of the magnet is the strongest. This force is invisible, but it's very real. I can make the force visible. Do you want me to?
Yes!
All right. I put the magnet down and cover it with a piece of cardboard. In this salt shaker are iron filings I collected. I sprinkle the iron filings over the cardboard, and the invisible lines appear.
Yes, these iron filings show the path of the magnetic lines of force. See how they are heaviest around the poles of the magnet?
Now, who would like to help me with a little experiment? All right, Susan. I hang this bar magnet up here. Notice that the two magnets attract each other.
There's a trick going on here. Watch.
Now you try it, Susan. It doesn't work. This magnet pushes that magnet.
I saw you, Michael. I saw you. You switched ends when you handed it to Susan. That's what you did.
Yes, Michael played a trick on Susan.
The poles on this magnet look the same, but they are different. One is marked S, and the other is marked N. They're called opposite poles.
Let's see what happens when the S pole of one magnet is brought near the N pole of the other. It is pulled toward or attracted. The rule about magnets is that opposite poles attract each other. Another rule about magnets is that two poles which are alike push each other away, like this. This is called repels. One S pole repels the other S pole. But an N pole and an S pole attract each other.
And now I'm going to show you how to make a magnet. You see this needle? It is not a magnet. It will not pick up the other needle.
Notice how Michael is stroking the needle on the magnet, always in the same direction, toward the pole.
This needle did not pick up the other needle before. Now watch. See? It has become a magnet. Now I'm going to make a compass which points to the north. I take this needle, which I've made into a magnet, and put it in the paper. Now I put it in the pan. Watch. See it turn? Which way is it pointing?
It's pointing north now.
See? We've made a compass out of a plain old needle.
The Earth itself affects magnets so that a magnet which can turn freely will turn its N pole toward the north. That's why we call it the N pole. N stands for north-seeking. What does the S on the other pole stand for? So Michael has shown his audience something really important that magnets do for us. Just look around and you'll see all kinds of uses for magnets. In the kitchen, for instance, magnets are used in many ways. They hold the knives in place. They are sewn into hot pads to hold them to the side of the stove. They are attached to can openers to hold the lid of the can so that it won't drop inside. But magnets have more important uses, too. There is a magnet in every radio and television speaker, and in every telephone receiver. Every electric motor has a magnet in it, too, an electromagnet, which is different from the permanent magnets we have been talking about. So the things that Michael showed his friends in his magic show are all important in our everyday life. Remember what these things were? First, that magnets attract only iron and steel. Second, that magnetic force goes through other materials. Third, that the magnetic force is strongest at the poles. Fourth, that opposite poles attract, like poles repel. Fifth, that you can make a magnet by rubbing a piece of steel on a magnet. And last, that the Earth itself is a magnet, so that the magnetic needle of a compass is made to turn toward the north. Why don't you get a magnet to experiment with and try some of these things for yourself?